So welcome again. Are we ready to go? Okay. So welcome to the second roundtable. I am Alicia Valero from Universidad de Zaragoza, and I will be leading this discussion. And we have five panelists who will explain us from an industrial and from a company point of view the challenges and opportunities of the automotive industry. So we have Marta Iglesias from SEAT, we have Steve Brown from Alpha Electronic Solutions, we have Julien Van Damme from JVD Consulting, Laurent Vautier from Next Move Cluster, and we have Elena Mocchio, Innovation and Development Department at UNI. So we will start this roundtable, and all our panelists will enlighten us with the challenges and opportunities that they see in the industry. And I would like to pose some questions, and if it is possible during your presentations, I think it would be nice if you could address them somehow, because during the Raw Materials Week we have seen all this supply chain crisis. And how do you see it from your perspective? Do you think it will continue to impact the European automotive sector? And how can we become more resilient? What is your view? And we have also seen during this week the tremendous dependency that we have on third countries, especially on China. And we see this seemingly unstoppable market that is coming. How can we do? How can we compete against this market that is coming? So if you would like, it would be great if you could also address these questions. And we will start our table with Marta Iglesias. She forms part of the Environmental and Innovation Research and Development team at SEAT from Volkswagen Group. So please, Marta.
Thank you, Alicia. Okay, good morning, everyone. It's a pleasure being with you here in this workshop. So I'm going to start with my presentation. So, there was a little problem with the format. Sorry for that. So I'm going to present our projects related to raw materials within SEAT. I start with a brief introduction of our R&D center in Barcelona. So we are working there more than 1,000 engineers from 30 nationalities, and it is a unique automotive research center in Spain because we are responsible for designing and developing cars not only for SEAT and Cupra, but also for the rest of the Volkswagen Group brands. And the raw materials projects that we are working on are embedded in our corporate strategy, particularly in the sustainability pillar. They are part of our DNA. All these projects that we are carrying out right now are based on previous research that we have conducted in collaboration with the University of Zaragoza. We started in 2017 with the Excite project, and we wanted to know what was the composition of a car. There was little literature regarding with material composition of cars. And when I met Alicia for the first time, and she explained me about the methodology regarding and based on the exergy property, we fall in love because we had an indicator for assessing criticality of resources, and we had several advantages because in terms of mass, We cannot compare iron and lithium, it becomes clear. And in terms of price, there's a lot of arbitrariness and volatility. So that when we found this indicator based on exergy, we could tackle this criticality assessment in a proper way. And there are several research articles in several journals that are supporting this methodology. So one of the important conclusions is that a car is composed of around 50 metals and metalloids of the periodic table. So one there said that the car is a mine on wheels, in fact. And here we have a comparison between a combustion car and an electric one. And you can see here that with the electrification of the car, almost all 35 metals of the periodic table are increasing their quantity in the electric car. And we know that cobalt and lithium have an enormous presence in electric cars, but we are moving from the orders of magnitude of grams, because in the case of cobalt, we have in a combustion car 20 grams, but in an electric one, we are calculating 12 kilograms of cobalt. So this is a huge and an exponential increase. But this is not the case only for rare metals, but also for base metals such as copper, which are multiplying by 4 its quantity, from 15 kilograms to 60 kilograms. So that was the basis for our ongoing projects that we are very proud of. Of course, Treasure, which we are presenting here today. And also, we are working on Eclipse and Reload, Spanish government-funded projects, where we are tackling other material fractions, such as plastics and key components of the electric cars. So I will skip this, because Paolo already introduced it. But in Treasure, we are mainly involved in the criticality, disassemblability, and recyclability assessments. And focusing on the criticality, which we led from SEAT, we made the exercise of trying to identify the critical metals, the car parts containing them, and we perform it with a methodology developed by the University of Zaragoza with a rarity indicator based on the exergy property, and as well based on the rarity intensity indicator, because there were some car parts that were light, or there were tiny car parts, but they contain substantial amounts of rare metals, so it was important to take into account the weight of the car part. And then we listed all these car parts, and we confirmed our suspicions that most of them were related to electronics, and that's control units, actuators, as Manuele has already explained. And for example, one important eco-design recommendation that we drafted is that in the case of tantalum, which is contained in the capacitors of the PCBs, nowadays, if the tantalum capacitors remain in the PCBs, we are irremediably losing this tantalum, which has a lot of exergy, a lot of physical quality as a resource, because we are applying metallurgical routes, as Antoinette has said, that are not fit for the recovery of tantalum. So this is an important recommendation that we have drawn in the project. So now I will explain Eclipse project. It's a 3-year research and innovation project formed by a group of 8 Spanish companies and led by Técnicas Reunidas with a budget of almost 8 million euros. And in this project, we are researching innovative separation and recycling technologies to be applied to the fragmented plastics coming from ELVs, from end-of-life vehicles. So in this project, as I said before, focus, I don't know where's the pointer, but it's here. Okay. Focused on the plastics, the post-fragmented plastics. We are targeting polypropylene and polyurethane, which are common plastics in cars. And then we are researching separation technologies because it's very difficult to separate black plastics, which are the typical ones in automotive industry, applying 4.0 technologies, robots, sensors, and so forth. Then we are researching several recycling technologies, for example, biotechnology, which is very innovative. And then we are studying as well the synergetic effects of these three technologies. And then the goal is to isolate and synthesize again the chemical specialties in order to reintroduce the polypropylene and polyurethane in new car parts. So we aim for this closed loop recycling. Preliminary results are shown here. There's few literature about the plastic composition of cars, and I don't know what happened. Okay. As you can observe here, cars contain around 17% of plastics, and there's a great mixology of plastics because we have around 40 types of plastics categorized in 20 different families, but this is challenging the recycling processes and the recovery. And the most common one, as supposed, is polypropylene with the 18%, but polyurethane and polyethylene have also relevant quantities. And then once we identify all the composition of the car parts, we develop this list of critical car parts, taking into account the weight of the car part, car parts that weigh more than 1 kilogram and that contain more than 80% of plastic content. And making this selection, we were able to select the car parts, the critical car parts that are representing almost 50% of the weight of the plastic composition of the car. And for sure, sorry, it's in Spanish, but of course, we detected the bumpers, the dashboard, and the fuel tank, for example, which are heavy plastic parts. And yeah, finalizing with Reload, we have started this project several months ago. Is as well a research and innovation project. Is formed by a group of 8 entities, Spanish entities, and as well with a budget amounting to 8 million euros. And here we are targeting key components of the electric vehicle. So, we are targeting the battery, the electric engine, and important electronics such as the charger or the inverter. And then the methodology behind this project is the same as in the other cases. We are studying the disassemblability in order to try to automatize the processes as much as possible. Then different recycling processes are being tackled. And then the ultimate goal is to reintroduce cathodic materials into new battery cells so that we are always targeting this closed loop recycling. So yeah, as I said before, in a nutshell, we are working on these 3 research and innovation projects, aiming for closed-loop recycling and applying this innovative methodology based on exergy. And yeah, the 2 ultimate goals and benefits of the realization of these projects is this development of closed-loop recycling, this collaboration with different partners developing recycling technologies. And on the other hand, we are targeting, which is more important for us, which is the beginning of life, drafting eco-design recommendations, designs for circularity, to be applied in our cars in order to enable the recovery at end of life. Thank you.
Thank you very much, Marta. We will have time at the end to discuss a little bit about the different approaches, and it is clear that SEAT is obviously concerned about all this and is trying to tackle through research the supply chain problem. Now let's move to Steve Brown. He's Senior Director for Automotive OEM Programs within McDermott Alpha Electronic Solutions. And he will explain us the reduction of natural resources in PCBs, fabrication and assembly processes. So thanks.
Thanks so much. So, we're there. Some delay. Good morning, everybody. So just a very brief explanation. McDermott Alpha, we're a material science company. We operate in a number of different industries. Our McDermott Alpha group is in the electronics space, so really focused today on two things. That is how we can reduce the use of natural resources in both the fabrication of the printed circuit board, the base PCB, and then secondly, a little bit about the assembly process. So when we buy the PCBs and components and we join them together, how can we impact those processes? So let's start with PCB fabrication. You know, some sustainability goals can be met by the materials choices we make. Many companies, our OEM customers and the tier ones and tier twos all have a number of different sustainability goals. But sustainability is no longer just a buzzword, it's something people are doing every day. Large OEMs have set these goals, suppliers are being pushed by their upper management and their customer bases to improve these processes. And in fact, there are actually some existing technologies which can help us achieve some of those goals. And I'm going to explain some of them today. So in the manufacture of a printed circuit board, we have multiple layers. Electronics have become more complex, we've all agreed that. So to connect these layers, we need to metallize the holes that have been drilled between the layers. We need to put copper, we've talked a lot about copper, between these different holes. So something called primary metallization is the connection between these different layers of the printed circuit board. How do we make these holes conductive? So they all connect together. So in most cases in the past, people have used electroless copper direct metallization. And what that process is a process to take the epoxy glass laminate and put electroless copper on as a base layer, so then we can do electrolytic copper to build a thick copper layer for carrying current and signals around the printed circuit board. So the PCB starts with this non-conductive material. We metallize, we activate, and we use copper or carbon, but copper is the most predominant system. And what we're going to talk about today is something called direct metallization, where we remove that electroless copper layer, and we directly make a conductive layer using carbon technologies on that. So why is it important, and what are the barriers? Well, the barriers quite often in the automotive industry is change, the fear of change. People don't like to do new processes because this is what we've done for 30 years, it's proven technology, everything else. I think with the sustainability goals, what's happened is people have reopened their eyes and said, let's think about these technologies and think about how they can help us achieve some of our different goals. So when we look at direct metallization, carbon-based metallization, you know, less water usage, less power consumption, lower waste generation, fewer chemicals, no precious metals, no formaldehyde in the process. It sounds like and I use the American basketball term, a slam dunk. It sounds like something which you would just switch to straight away. But at the moment, we're really trying to promote this technology because it has a big impact on the technologies. Now, We actually have two different technologies. My company, McDermid Alpha and McDermid Enthone, is a combination of a number of companies which came together in 2015. So both Enthone and McDermid brands had two different parts. But all you need to know here, and what's key, is that on the left-hand side is the electroless copper process. You can see 16 steps in that whole process. So you imagine the PCB production line. And when we go to either our black hole or shadow plus type technology, we reduce those number of steps very, very significantly to achieve the same result, a metallized copper hole. So what we see in this is a big reduction in chemical consumption and waste treatment. From our perspective as a material supplier, we actually supply less material in the carbon-based technologies, but we're committed to promoting these sustainable technologies through the PCB supply chain. So we look in the different areas here. The amount of wastewater, the amount of chemical replenishment, all has a massive amount of saving in that whole process for the whole piece. So we really think about this in 4 sections, and when we get asked questions about sustainability, we're very aware that there's lots of components to the word sustainability. It means many different things, and there's lots of components to it. So we really look at things such as power consumption, waste treatment, water usage, and also the energy used in the actual manufacturing process itself. How much energy is consumed in every square meter of printed circuit board used today. A few of the other speakers have noted that if we look at the car, Marta called it the mine on wheels. Some people call it a computer on wheels. The key thing is now we know there's somewhere between 60 and 100 PCBs in most cars that we see on the road today. So in terms of square meters of PCB per car, it's got much larger, but also the number of layers of the PCB as well, because of the complexity of the electronics has gone up in a big way. So if we look at the CO2 comparison between the different technologies, we can see all of these have been mapped. I'm not going to go through them all now, but very much we're seeing very big savings in much of the energy and water consumption in all these different processes for the fabrication, in regard to scope 3 and of greenhouse gases. So what we've put together for our supply chain is a tool to try to measure the comparative differences. So how this works in the industry is we need commitment throughout the supply chain, typically. I think most of you will know that the majority of PCBs fabricated today are fabricated in Asia, largely in China. A lot of assembly happens in Europe, a lot of assembly happens in Americas, it happens all over the world, but the base PCB that companies like Bosch or Continental will build in Stuttgart or in Reutlingen or in anywhere around Europe has actually been shipped from Asia typically. So to get the supply chain to move, we absolutely need to encourage through the whole supply chain, from governments, through OEMs, through the tiers, to show what impact these things could have. So this is just an example of a tool which shows the amount of CO2 savings, for example. It's one of the tools we can have by switching from electroless copper metallization of PCBs to carbon-based technologies. So if we look at a summary of direct metallization, proven reliability, it's a much greener technology compared to what we have today. The great level of material compatibility, and there's quite a wide installed base, but one of the industries which has resisted the change has been the automotive industry, because it's a newer technology in many cases. So that's the first section of my very brief presentation, and we're happy to have further conversations on any of these. So we're going to move on now. So we've bought the printed circuit board, we've purchased all of the components for our design, and we have to assemble them. We have to make a functional circuit. So if we look at that, how can we reduce, for example, CO2 emissions in PCB assembly? Well, we can reduce the process time, how fast we can process the materials. We can reduce process temperatures. We can eliminate process steps. So quite often in a PCB assembly in the past, we would print some solder paste, place components, put it through a furnace, put through-hole components on, pass it over a wave solder machine. There's ways to cut out certain processes, and to enable the use of alternative substrates, so we can use different process temperatures and settings. So we get a lot of questions from our direct customers the big tier one suppliers, of how much energy is consumed in the production of our materials. So we will ship, for example, a tube of 1 kilogram of solder paste, a printable form of solder, to an assembly line, and we've got calculations on how much energy is consumed in our manufacture of that product. The reality is it's a very small percentage compared to the amount of energy consumed in processing this material at our customers' plants. So our bigger impact we can have on the environment, on sustainability, is making materials which they can process more efficiently and impact their own energy consumption in different parts. So a good example here is if we sell 1 kilogram of solder paste in a tube and we sell it to someone making an engine control unit, typically there'll be about 2 grams of this material on every PCB. So you're going to make about 500 PCBs out of this 1 kilogram. You're going to put 80 PCBs through the oven every hour, and the line consumption, power consumption through the furnace is 25 kilowatt hours in the case, 25 kilowatts per hour. And that 1 kilogram of solder paste will last for 6.25 hours. So you're going to consume 156 kilowatts of energy just to process this material. In comparison, we think is about 3 kilowatts of energy consumed to produce the material in the first place. So how do we get the big impact on that? So the first one is the use of lower temperature solders. In 2006, we moved from tin lead solders to lead-free solders, and what that did is increase the energy consumption very significantly in the assembly processes. And that's something which we can review and we can look at many times. But what we're looking at here is the ability to use materials which remove a number of different steps, so you can reflow and wave solder become one single process because the components can cope with the lower temperatures. But also the reliability aspect of these materials has been improved and improved and improved through metallurgical dopants over the last few years. So when we look at an example here of the energy used in a reflow system, so this is the heat process used we print the solder paste, we put on the components, and we pass it through a furnace, a multi-stage furnace, and these are high temperature processes. So typically what we're seeing in energy consumption is about a 40% reduction going from a standard tin silver copper, which is SAC alloy, to a bismuth tin silver alloy, which melts at a much lower temperature. And you can see on the screen here that the amount of power consumed in the oven, in this one is 29.3 in this example, and the same process using 17.8 kilowatts per hour of energy to run the actual the oven in that case. The next one, of course, is still being used, and there's an image here of a wave solder process. So this is a process where typically is used today for connector soldering, so the big connectors on the edge. And in this process, typically, you have up to 500 kilos of molten solder, which is pumped as a wave, which skims the bottom of the printed circuit board for this soldering process. We strongly believe, removal of this process is mandatory. It's a lot of heat for a few solder joints. So in many cases, what we're looking at is how can we change this? So if you can't remove this process, one of the ways is to use nitrogen in the tunnel, and the amount of wastage of material is reduced very, very significantly because of the lack of oxidation of the material and the greater performance of the material in the whole piece. Has a small impact. We recommend to remove the process. It still exists in some cases for some large connectors. So the alternative to wave soldering is what happened? I pressed the wrong button, that's what happened. The alternative is selective soldering. Selective soldering, instead of having a 500 kilo bulk of material, which we're heating to 260 degrees and pumping to make a few grams of solder joints, this is a selective process where the PCB is moved up and down over a small nozzle of molten material, which we have a flux material on again. And this table really here shows what the impact on cost and material consumption is on those materials in the assembly process. So that's everything from me. It's a very quick sketch through some of the ideas that we have and some of the materials. I think the key messages to this audience is there are decisions that can be made today on process choices which have a big impact on material consumption, on energy consumption, on water consumption, and on waste chemicals from different processes. Thank you very much. Thank you.
Thank you very much, Steve. Very enlightening, your presentation. Now we will move to our third presenter. He's Julien Van Damme. He's CEO of JVD Consulting, but he has had a lot of influence in Honda and still has, I believe, because he has been working for many, many years in the automotive industry, and he will enlighten us with a presentation on the new ELV regulation, challenges for the treatment chain.
Thank you very much. Yes, thank you. Okay. Here we are. Good. And during the latest weeks, I have been diving into the draft ELV directive and made some analysis. And from that analysis, for this presentation, I picked up some elements. What will this presentation be about? It is about the introduction of the ELV regulation itself, targets and tools that are foreseen in that presentation, in that regulation, support that is obliged or mandatory by the producers, financial guarantees that are foreseen, promotion of, very important, of reuse, recycle and recovery, because this is one of the challenges and opportunities for the business. And then another challenge and opportunity is the result of the export restrictions. Just to make a kind of overview, the basis of the ELV regulation is the Green Deal and the REFIT program. That means that for the Green Deal, we try to optimize the resources, and reason for optimizing the resources is the permanent risk of supply of raw materials. And then also minimizing pollution during the treatment of the ELV. Reducing pollution, minimizing pollution also means that we need to recover more materials out of the products. The REFIT is important to mention that there it is said that the eco-design of the product should be improved. So that's also one part of the ELV regulation, the new ELV regulation. And also we must ensure that the waste is managed in a sustainable way. Also meaning we have to recover as much as possible materials out of that waste. The next step is the challenged improvements that the ELV regulation is setting forward. Here, important is that previously we thought a good functioning ELV treatment chain, but after further analysis, it means that it is in fact suboptimal and some improvements are possible. Another element of the current ELV directive is that a lot of end-of-life vehicles are leaving the market. That means that some resources are going out of Europe, and of course, because of the risk of material supply, we want to keep all this information in Europe. Another problem is that there is only, the ELV directive only covers limited number of types of products. That is now being extended with motorcycle, buses and trucks and their trailers. So also that is an increase of the volumes that can be expected in the treatment chain. Circularity is important. Of course, this is part of the type approval of the vehicle, and type approval of the vehicle means that it is at the production, the design and the production phase of the vehicle that is being considered. But more important is that, as I said before, it's important to keep the resources here in Europe in order to guarantee that we can further use extend our mobility as such. So management of the ELVs itself is more focused, and also the export of used parts is being better controlled based on that regulation. That I already had, I think. No, it's something else. So keeping resources again is one of the focuses, and management of ELVs and controlled, meaning avoiding that ELVs are being exported, making sure that they are treated here in Europe. The policies, again, is focusing also on keeping resources in-house, and also to make sure that the resources are better prepared for reuse. So resources, using less resources by using recycled materials, recycled plastics. And from that recycled plastics, we will have, in a further stage, 25% of the plastics that needs to be recycled in closed loop, this product to product. Then also a stricter treatment of the ELVs, stricter definitions. I come later on this one, and also increase of the recovery of raw materials, also including critical raw materials, as we have seen before. So also this is one of the targets of the ELV regulation. Collect more, no export as much as possible, unless it is really, it concerns really used parts, used vehicles. We have some other elements here, the EP extended producer responsibility, and the intention to cover more vehicles as such. More stringent definitions is quite important here. It focuses on reuse, meaning using parts, for replacing parts. Recycling, in my understanding, means that the material is being reused as almost the same material, and recovery in the definition specified here is that the material is being regenerated as another material not intended for incineration. So these are the definitions for which we, or not we, the car manufacturer has to make sure that his vehicle is 85% reusable and recyclable, and 95% reusable, recyclable, and recoverable. This is not only for the car, it's also for the motorcycle, the buses, and so on. What are the challenged applications which are by some countries which are considered as being recycled. That's shredder waste, which are sent to old salt mines for stabilizing the salt mines, and also the use of the plastics coming out of the shredder process that is being used as a reducing agent in blast furnace. These two applications are not really covered by the definitions I have just shown. So minimum recycled content is also important. So we start with 25% recycled post-consumer plastics, because I know from my colleagues from the car industry that production waste that is just shred and put in production again was also considered as being recycled. Here it's really specified, it must be post-consumer plastics, out of which the 25, there is another 25 that should come from a closed loop process. This is, I think, the most important thing. Other elements like proof of recycled steel and recycled other metals are still subject to further analysis and will be made obligatory in a later phase. So the result of this is that promotion of recycling is one of the main aspects of this regulation. And the big question for the automotive industry is in a very first phase, is how to get those recycled products. Didn't we have that already? Then we had the fact that we want to get as much as possible, pure as possible materials, whereas the regulation is promoting for urban mining. That means they want to have the materials as pure as possible, and for that reason they are promoting dismantling for a number of elements that you can see here. There is one exception. If there is, can be proved that the materials can be retrieved from post-shredded technology, that's also allowed. But here, at first instance, they want to make sure that the elements are there. Another element in the directive is design elements, and what is there important, that is that they want that the materials, the parts also can be removed as easy as possible. Basically, this is something that the at least the car manufacturers are doing already, because they want to make the work for their dealers as easy as possible. But also this is contributing to the dismantling possibilities of a car. So this removal and replacement, at first instance for parts, but also for their components, and later on for further treatment, must happen at a non-descriptive way. That we already had. What is also important to see that there is a kind of vehicle passport required. That means that information must be available for also the dismantler in order to promote the dismantling of parts and of components so that they can be reused for further operation. Why 7 years? Because this is just an idea and needs further elaboration by the European Commission. Here again, what is the purpose of these rules is the promotion of keeping the materials and the parts as good as possible. One question from my side is IDIS not the tool to be compliant with these recommendations? And maybe IDIS must be enhanced, but anyway, this information is already available for the dismantler at a free of charge basis. Financial responsibilities, yes, there might be some cost, but the question is whether there will be a cost. And in this respect, the European Commission anticipates and says, as it was in the directive, that the producer has to pay for the cost occurring during the treatment of the ELV. All costs? No, only that portion which is not covered by the revenues from the treatment of the end-of-life vehicle. How making sure that this cost can be covered? This is either on an individual basis based on a guarantee, a bank guarantee, either by joining an OPR, an organized producer responsibility system. Also important is, and that was not in the directive, that is the country where the car or the vehicle has been sold first will be responsible for the treatment of the ELV in another member state. Also important is that the reuse of parts is being promoted. And there are different possibilities. Of course, one option is that parts from an end-of-life vehicle are being reused. Another possibility is that that part is being remanufactured or refurbished. That should be promoted, and how to promote this? In France, there is already some rule that every dealer has to offer the opportunity to use either original parts, either used parts. Another option is that, and that is included into the legislation, that is that the member state can apply a lower VAT rate for reused parts. In Belgium, that means that a VAT rate of 21% should become 6%, which is indeed a quite significant reduction of the cost for the consumer. The targets remain as it is. Of course, we are not only having the cars, but also other vehicles. And also another target is that the waste management operators has to achieve 30% of the total weight of plastics recycled as such, of the plastics in the car. Again, this is part of the promotion of the urban mining policy. Used car, there is a definition of used car, there is a definition of end-of-life vehicle. End-of-life vehicles cannot be exported anymore, must be treated in the EU. which is in fact a good thing. And for that one, we have some information that is to be shared through a system which will be developed by the European Commission, Move Hub. So also there, the target is to avoid losing the materials. More vehicles has been explained, so more business. More parts and components to be retrieved, more business. More separation, more business, but not for the dismantler, but for the shredders. More materials, more material flows to be handled. Also that is an important element for opportunities. And of course, as there are more values, as there is more materials, there is more value as option. So these are the opportunities, and if there is a deficit, the manufacturer will cover it. Thank you very much.
Thank you very much, Julien, for this explanation about the challenges that we are facing for end-of-life vehicles. We will have a little discussion about this after the roundtable. And now let me introduce you Laurent Vautier. He's project manager in industrialization and operational excellence at Next Move cluster, one of the most important clusters, automotive clusters that we have in Europe. And it's your turn to explain us which are the challenges and opportunities in the automotive.
Thank you, Alicia. Good morning, everybody. Thank you, Julian. So it will be a good introduction for the next part. So I will talk to you about the clustering and mainly about the ongoing and in-progress activities and initiatives. So just briefly, Next Move is one of the most important cluster, competitive cluster in France now. Our main role is to promote innovation and competitiveness. So for that, we are gathering 550 members, mainly in the area of Paris and Grand Paris and Normandy, that represent 150,000 people working on automotive and mobility. So it is people that we are able to touch every day with a huge amount of vehicle produced per day, for sure. So regarding the today discussion and activities, so first of all, the main missions of the cluster is really first to animate the members, animate the ecosystem that we have, to make the link between our members, to build bridge between them, to allow collaboration. We try to support them, our members, for their innovation, new project that we are able to support them. Main activities also about growing the competency, innovation, performances. We also are part of structuring project as Treasure, for example, big initiative for European project, for example. And we have a main new topics right now is about skills, training formation. We bring formation, and we also make collaboration between our members regarding their skills and collaboration. So regarding the circular economy, so we are really present in all the different phases of the vehicle life, starting from the design, conception, and production, for sure. So we are at the very beginning. We are activities, for example, on the raw material, on the appropriation of new materials. So we bring some animation, information, communication, dissemination about these raw materials. We support project also from the emergence, new project. So I will present you some initiative coming from our members just after. In the design phase, in the eco-design, eco-conception also, we support our members with labelization. I would say we put a stamp on project ideas just to also to get some subvention from the government to put in light some new projects. We also work a lot with our members for alternative solution, as mentioned by Steve. So it's really important to identify new ways, just change the way we work, change the way we develop things in order to provide new values. One of the main topics right now also for us is the supply chain collaboration to work at the local. So we have a lot of actors, members, but we have also other sectors that are working on the same area. So we are working with them for synergies, hubs, just to try to work together between them. We provide also, I would say, service economy information, especially regarding the other mobility. We are mainly discussing today about automotive, for sure, but we are also putting lights and try to develop other mobilities, so lights mobilities, for sure. And also, we push, and this is a new tendency, to change the business model. Sell a car, sell a bike, sell a motorbike. So it's just changing right now on the way we work on this business model. This is for the economical actors, I would say the developers, the builders of the car, but we also try to impact the users. So for the responsible use, we'll talk about the carbon footprint of all the vehicles, and also for the use, introducing for sure the electrical vehicles. And we try to change the social responsibility, to change the mindset about this social responsibility of using a car. One of the today discussion of Treasure is really about the second life, extend the time life and make the product work longer, but for sure, and also introduce maintenance, repairing, disassembling of these components to be able to reuse it. But this is a part of the activities today for next move, and also at the end of the loop regarding the waste management, we have project support on the waste valorization for sure, and also try to connect in the sector the different actors to be able to get a collaboration between them. So my waste became your new material. Our milk run can be gathered just in one track, just to be able to limit the carbon impact of our activity together. So just few initiatives today on the road. So for sure, for all the different topics that I present to you, we have several projects ongoing. But if we just look at the different initiatives, so for the first one, for the raw material, so we have specific committees, members that are working together, and on a yearly or twice a year, we have plenaries on discussions about project presentation on new raw material, new impact, some of the discussion that should be probably be discussed during this raw material week in Brussels. But we have, for example, next month a specific plenary on the raw material, especially on the critical material management. Alternatives, innovations. So we talk about dependence to China, for example, for microelectronics. One of our members, Diam Fab is dealing and try to innovate, innovate on the synthetic diamond, specifically applied to the semiconductors. So this is a new way to limit our needs in terms of material, for example, coming from outside France. We can also, I would say, manage, pilot some projects. So next move with LCN is piloting one of the projects with local, regional subvention to collect all the needs, all the sectors, as I mentioned, for supply chain collaboration and waste management collaboration, especially in the area of Normandy and Paris, where mainly most of the automotive companies are located. We have also Mobion, is a scooter company that built eco-design e-scooter, built with a lot of different modular parts that can be bring together and change together, repair individually really easily, and they decided to change the business model, not to sell scooters. The aim is not to sell thousands and millions of scooters. The specificity is the lifetime of the scooter is evaluated at 20 years, and they are able to change it and not sell the scooters, but to rent only the scooter on the use, to change the way we use it, and they deal with the maintenance and the repairability of the scooter itself. Lormoto, you probably know the old Twingo vehicles. We are still have a lot of Twingo, especially in France, running on the road, and the Lormoto project is really to electrify. It's a retrofit of the previous Twingo. So the project is now on great advance because it's validated. First concept is completely down. They are running into industrialization of the Twingos, and they are able to provide a rental solution by 200 euros per month for the location of the 100 electrical Twingo starting from the end of the year. And Orano, you probably know Orano as a nuclear supplier. So they enter in automotive industry now with a specific project. They built 2 new sites to develop the solution of the recycling of electrical batteries, especially to collect and renew one of the main components that we are talking about that are critical, as the lithium, the cobalt, the nickel, the manganese, or the graphite. For sure, we have initiative and promises on all the different pillars of the circular economy. And what we bring as a cluster is the knowledge, the ecosystem, but in order to achieve our main goals, to get resilient, to get for this independence strategy, so we are already focused on the main topics, which are develop innovative solutions as alternative and create new value. Look at emerging markets, new solutions, new markets, new opportunities, new business models. We are in close contact also with the government. We are allowed to provide a good orientation for our members to the right desk with the right speech to get money, to get a subvention for their project, for their innovation. We work also with agility to develop supply chain that are agile, and as much as possible to implement local synergies especially even on intersector, not only on automotive, work together. And for that, for sure, we have two main pillars, which are develop the circular economy. As you see, we are working on the 7 pillars, and our main DNA, I would say, is really the continuous improvement. I would say today that even if we have 1% waste in our production, so it's just waste, so we can keep on going with a continuous improvement and to provide solutions to our members to get close to the sky. That's enough for me. Thank you very much.
Thanks a lot, Laurent, for pointing this very important aspect that clustering is becoming more and more important in general in the industries. And last but not least, we have the pleasure to have here Elena Mocchio. Elena Mocchio is Innovation and Development Department at UNI, and she will talk about something which is essential in general for all industries, but I think for the automotive industry is extremely essential, and it is about standardization. So please, Elena.
Thank you. Good morning, everybody. It's a pleasure to be here. And yes, I'm responsible for the Innovation and Development Department in UNI, the Italian standardization body, and we are partner of Treasure. The role of standardization is a cross role. I mean, it can be, according to what I heard and to all the different presentations, I always spotted something where standardization could be included and couldn't be considered. So the idea is to try to answer to the two questions by saying that standardization might help, might support to address the issues of critical raw materials, and might be part of the solution. Of course, it's not the solution, but it could be part of the solution. I don't know if I managed to, all right, thank you very much. So, okay, right. So what I'm going to show, or trying to show, is how standardization can support, in general, the issue relevant to critical raw materials. UNI is part of SAN, which is the European Standardization Network. There are 34 national standardization bodies, which means that we are including all European countries, European Union country, and also other countries around Europe, of course. And what we are starting to do, and what we did also, when the Critical Raw Material Act was published, SAN promoted a kind of position paper. And the idea is to show how standardization can support the Act. Because for sure it can be a way to boost standardization in different areas and therefore to develop European standards. Standards are developed by the market, for the market, with the involvement of all stakeholders, coming from any different organizations and sectors. So they are overarching and including all different aspects, and they are based on consensus. So it's a long process, but at the very end, you have documents which are agreed by the market and can be used by the market as tool to support the market itself. So the idea was to support and to encourage the European Commission to work to support standardization activities on critical raw materials according to different aspects, of course. We can go through the terms and definitions, starting from terms and definition, which is a starting point, but then also methodologies for an analysis or for many different, or for processes and so on. So it's in the position paper also agreed on the fact that the Act should support necessary standardization activities and should link with international standards. Because I'm talking about European standards, but we do not have to forget that we have the ISO standards and the ISO context, which is the International Standardization Network. And so the link is very important to make a coherent approach to the critical raw material issue, let's say. And also to provide some background, since Analec is also in the position of provide background information about what already exists or is ongoing for what concerns standardization activities. And finally, the idea is also to ask to the Commission to consider the fact of using harmonized standard in order to support the critical raw material approach through all over Europe. Harmonized standards are standards which support the regulations. A typical sector where you can find our harmonized standard is the construction sector, health sectors. So these are very crucial sectors, and critical raw materials is a crucial sector at the European level for Europe, as we understood today and during this week. So what's going on at standardization level? We have already some technical committees dealing with critical raw materials. We have some technical committees within ISO. That's why it is important to link with the ISO activities. And a brand new technical committee on rare earth at European level, which links with the technical committee already settled at ISO level. Just to give you the idea, the rare earth technical committee is managed by DIN, which is the German standardization body. And the technical committee relevant to specialty metals and minerals, which is the critical raw materials, it's a different way to address the same issue, is managed by AFNOR, which is the French standardization body. So this just to give you the idea that, yes, we are working at the European level, we are working at the ISO level, but there's a strict link and there's a strong European commitment for what concerns standardization in critical raw material context. And what are we trying to do thanks to Treasure activity? We are trying to develop a SAN workshop agreement, which is a pre-standardization document. It's a typical document developed within the time frame of a European research and innovation project, because standardization takes longer than the lifetime of a project, and above all, standardization comes at the very end of a project because it should somehow collect the result of the project itself. So the tool for collecting the result of a project, of a research and innovation project, can be, for standardization purposes, a SAN workshop agreement, and the idea is to provide a document which can provide information about the methodology to improve the recyclability rate of critical raw material coming from cars. So again, we are talking about more or less the same issues from different perspectives. The SAN workshop agreement is, as I said, a pre-standardization document which is developed by a working group which is called SAN Workshop. So don't get confused, it's a working group, so it's a platform where different interested parties can exchange and develop a standardization document. And the idea is to develop a document which defines a method to support the automotive actors, so all the different subjects involved in the automotive sector, in identifying the presence of critical raw materials and in the electronic parts, and also addressing the disassembling, separating and recycling these components. So it's the synthesis of what we heard today from different perspectives. And I think it's very interesting because somehow in this document we should collect the different experiences and try to promote a methodology, a common methodology, which can be used by everybody, so in a harmonized way. Maybe also providing some examples, because I think it's important also to provide the theoretical approach and then the real approach. And then the idea, thanks to this SAN workshop, is to improve the recyclability rate for critical raw materials coming from car, and to support policymakers, because again, as I said, standardization can be a tool to support policymakers in order to address what is going to be with the future digital product passport. We heard about the end-of-life regulation, and that there's the idea of creating a passport, a circularity passport for the vehicles. So something needs to be done also to address this kind of issue. And well, a SAN workshop agreement can start to pave a way for future, to address these issues, and for future standardization activities, maybe more specifically, which more specifically will address specific issues linked to the circularity in the car industry. The activity is the development of a SAN workshop is a very agile and adaptable procedure, and the document is also, the SAN workshop is also, would like also to address not only the car industry, but maybe somehow address also other industries, or provide some hints about how to address the recycling issue of components, of electronics component in other sectors, in order to recycle and reuse critical raw materials. In December, the 13th of December, we will have the kickoff meeting of this SAN workshop. It will be a hybrid meeting, which means that we will meet in Milan at Uni premises, but at the same time we will have a possibility to have the online meeting. And any interested party can take part to this activity. So it is open to anybody, which means in Europe and outside Europe, which is a challenge again, because it would be quite interesting to exchange ideas with market players coming also from outside Europe, taking into account the impact they have actually for the critical raw material context. So if you want to participate, the information are available on the SAN website, but in any case, should you want to take part to this activity, you can contact me and I will provide you with all the information. And again, the idea is to start this work in December this year and to end, so to publish the final document by the end of the project, even a little bit before, so we can disseminate the content of the SAN workshop agreement. As I said, the SAN workshop is a very flexible platform, so the participation is open to any stakeholder, and inside and outside Europe, and it's a rapid way to develop a pre-standard. And as I said, it's a tool to innovate and to pave the way for future standardization activities. Of course, we will not be able to address everything with the SAN workshop agreement, but at least we can start from a starting point, and then to improve the content of the document little by little, also with the support of other projects. Because the idea is that these are documents officially published by SAN, and they last longer than the project itself. So this means that after the publication, we have 3 more years to check the use of a document. So the market, I mean, has the time to read and to check the use of the document, and then to decide, going back after 3 years, if the document shall be updated, shall be withdrawn, hopefully not, or shall be modified and become a European standard. And then if the market decides to reconfirm the document, we have 3 more years. This means that from the publication, the lifetime of a SEN workshop agreement is 6 years. It's a legacy from a project which can be used by other projects, by the market in different ways, and it's something which lasts longer and can be then developed into a full standardization document, maybe within those technical committees which I showed before. So this is all from my side, and of course I'm available for any information, and you can contact me in case you want to join the SEN workshop. Thank you.
Thank you very much, Elena. Well, we have seen very illustrating presentations, and we have some time for discussion. And I would start because Julien, he gave us a great presentation about the end-of-life vehicles. And I would like to ask you also for the manufacturers, also for the OEMs, what do you think? Is the European industry prepared for this end-of-life new directive, end-of-life vehicles directive? Is it ambitious enough? How about our colleagues from outside Europe? What if they are not taking into account our legislation? Are we losing competitive in that case? So, I don't know, maybe, Steve, do you want to start?
I think it's a complex question.
It is.
And there's many parts to it. I do think that one of the challenges that we have in Europe is this very experienced industry, which gets very set in its ways of doing things the way it's always done it. And quite often we look at our new competitors, especially in the electric vehicle space. That's, we've described that as the democratization of the auto industry. It's easier entry. You don't have to develop an internal combustion engine. You can buy a battery pack, buy an electric motor, buy a power electronics unit, and you've got the basis of the powertrain for a car. And I think they tend to be more nimble. They're newer businesses. They're not set in their ways of doing things sometimes. So to the question of, are we competitive? I think we absolutely can be. I think we have all the experience and skills to do so, but I do think we have that challenge of, rethinking how we do things. And one of the big challenges I think we see, especially in the automotive industry, is this groupthink of being very careful and very cautious and taking a long time to make changes. And I think that's the challenge to our competitiveness moving forward. Yeah.
Definitely. What is the case with SEAT? And then we will know the opinion of Julien.
Yeah, we think that it will be a great challenge to reach, for example, the target related to the recycled plastics. And nowadays, we have quantified that around 10–15% of the plastics are coming from recycling. However, they are coming from post-industrial processes. So reaching this post-consumer target will be a great challenge. And there are a lot of sectors competing for plastics. We are not alone as automotive industry. And there's also this challenge about incorporating closed-loop recycling, and we have seen now in my presentation that we are making the first steps towards the closed loop, but we need time to implement it, so it will be a great challenge, of course.
For sure. Julien, what's your opinion?
Thank you. Well, first question is, of course, will we keep competition with non-European manufacturers? I think the legislation, the regulation is quite clear. Most of the targets are included into the whole vehicle type approval procedure. So that means that in order to get allowance to come onto the market, every product has to comply with the basic rules of the regulation. Are we ready? Are we as Europe ready to comply already now with that regulation? I'm afraid it's a little bit too early. We need some more time to adjust our processes to make sure that the required recycled plastics are becoming available on the market. Luckily, we have some time in order to implement this. I think we have some between 5 and 7 years in order to comply with those regulations. So luckily we are sufficiently, in Europe we are sufficiently flexible. That's something that we can say. We have proven that this can be done. So I'm quite confident that at the end we will comply.
Great. Do you want to add something, Laurent? Looking into, for instance, the French manufacturing companies?
No, what I just want to continue on Julian, what Julian says, that for sure the race is not over, but we don't have the same, I would say, thanks to this kind of project as Treasure, because it's just showing the way on the field, on the industrial actors, we can see that there is a different knowledge. This is why we are trying to disseminate this information and try to inform and train them. Big groups are already ongoing and try to implement. On small actors, we can see that we are really far from this behavior, for this mindset of implementing, changing the way they develop and they disassembly. But even at the beginning, how they develop a product or on the PCB. So this is why it's really important to have this kind of project and going with the time, so we will be able to change the way we really develop and reuse this product and components.
Exactly, and time is here essential. And this is a question for you, Elena, because you explained us the process of creating a standard, which is very not time consuming. And do we need to accelerate somehow the standards processing process so that we can start as soon as possible?
Yes, I think that it's something that needs to be addressed. Pre-standardization activity is already something which helps to speed the process of standardization as creation of a full standard, taking into account that also a pre-standardization document can be used for example, for certification purposes. So it's something you can refer to, even if it's not a full standard, but still it's a reference document. And yes, standardization is trying to speed up the process of producing technical documents. But as I said, the process is time-consuming because we build our documents on consensus, on transparent processes and on consensus. And when you have to make people agree on fundamental concepts, on methodologies and so on, and each one represent different interests, then it's not easy. But it's our work, and we have let's say, the tool and the capability to speed the process and to help the market to help themselves, because this is the issue. And so I think that standardization can really support, of course, this new deal, let's say. Of course, we need the support from the market, because by ourselves we cannot do what it is expected. And we also need the support from the legislator, because that speed up a lot of activities, because it is asked from the legislator, and in this way we can move a little bit faster.
Thank you, Elena. Well, we are running out of time, but I would like to address one thing that came with Steve's presentation, and he talked about the impact also of the whole supply chain, that it is not only the environmental impact of one specific chain might not be that great, but it comes from the beginning. So we have really to look into the whole value chain. And my question here, and also considering Laurent's presentation about the collaboration, is how can we impact from the OEMs, from the manufacturers, the car manufacturers, from the cluster, how can we impact on their traceability, also on the, on the flowing of the information from the very beginning, from the mining companies until the car is in our hands, and also the end of life people, right?
Yeah. I think, yeah, it comes from, you know, a complex and very established supply chain has resulted in, you know, greater complexity within cars at a time when we're trying to create more simplicity. And a good example is that as we've gone through the automation of the driving experience, the whole ADAS subject is a very interesting one, because what we've gone from is, you know, adding on more functionality over time with auto braking, all the way from parking sensors some decades ago to things like auto brake and some different parts, and eventually the end goal is the fully automated car. But if you look at how that's happened, car manufacturers have integrated more and more sensors into their vehicles, like cameras, sometimes LiDAR, radar systems, and each of those sensors today comes with its own control PCB, which then feeds information to a central computer. So that's had an explosion of the amount of electronics in cars, the individual PCBs. And if you think about the processes to make them, the PCB fabrication and the assembly that I talk about, and the amount of materials and energy and cost associated with that is massive. And we compare that to some of the new EV manufacturers who took a completely different approach and just designed one central computer where the sensors directly feed into the information to that one central computer. So they go from having a multitude of different PCBs in different locations to one central computer. So it's almost starting again and redesigning how we do things. And I think that's an important consideration, and we have a great opportunity and experience to do that. But it does require us to rethink, you know, how the supply chain works and how we integrate electronics into cars, because, you know, if we look at the evolution over the last 30 years, it's just been adding more and more modules and units into vehicles, which has got us to where we are today with the amount of, you know, copper cables and interconnection of materials in cars. And I think that's a consideration that the established manufacturers are working on now, and I think it'll have a big impact really on the sustainability, the amount of weight in the vehicle, you know, the amount of energy consumed in the whole supply chain to produce that functionality.
Right, and someone would like to contribute to that? Okay, any questions from our audience? Yes, please, Manuele.
I have a short question for Steve. First of all, I really agree with a lot of things that you said, that we need to improve the processes, how we produce the printed circuit boards. But allow me to ask a critical question. you said we have to reduce the natural resources during the fabrication, but you showed that to increase sustainability and save energy, you would move from a different solder paste that uses bismuth. And isn't that also a critical raw material?
Yeah, I mean, there are other options, of course. That's the one that, had been identified. There are indium-based materials which also have an impact. That has a cost impact in the whole thing. It's a big subject because actually, in reality, we've had quite a few conversations with large tier ones, and the reality is that if you have something which operates at the same temperature but extends life by 2x, or is more reworkable, then in total LCA calculations is actually a better option. The problem then again comes into the demands coming through the supply chain, and I'm going to be very critical now. Sometimes they're not joined up demands, so there's just a very headline demand that would come from a car maker to say, we demand a 30% reduction in energy consumption in your production in the future. So at the moment what's happening is a lot of baselining, people trying to understand what is the current situation, so then what are the options to deliver the percentage reduction. But it's not always completely joined up thinking, because that reduction could actually have a bigger impact on a total life cycle analysis in the whole paces. So what we're trying to do, as a global materials company is try to be as open-minded as possible and develop, options which can solve, some. We'd like to do all, but some of the problems. And the challenge with the bismuth addition is that it is a critical raw material, but it's an abundant raw material, and it's relatively low cost. And automotive cost always becomes a big aspect. And the problem with it had been for years that the bismuth-based alloys were quite brittle, so they were not very reliable. So all of the materials science development has been about how do you add in small dopants to those materials to make them be able to survive in a car. But it's a good question and a great point, and something which we go around all of the time. And I think the reality we face as a material supplier is, people talk about sustainability and environmental friendliness. We supply chemicals, and some of the stuff we supply are not things which we know have impact. So I think our mission is to create broader understanding of the impact of decisions, and so we can balance things every time.
Great, thank you.
Thanks.
Okay, last question, because we are already out of time. Please be short.
Thank you, Alicia. Just a question that ties on to what you said about the data. Elena, I was happy to see that you also touched on the digital product passport, and the tools I showed, which we developed to assess recycling, are also used in industry to build $1 million new plants. There it's quite easy, because that technology and that industry, minerals processing, exists already for a long time, to make the link to the data, to the input data. Also with relation to what you explained, Julien, on the ELV directive, there's a lot of information required, also on different levels. If you speak about the tire, it's rubber and a bit of steel. But if you speak about CRMs, it's a completely different level of information required. How do you see that will evolve? How in Treasure we are linking these things in the platform which is being developed, that the data link is difficult. How do you see that will manage in practice?
Yeah. At this moment, it's IDIS who is the tool in order to find where certain materials are located in a car. At first instance, I think that this tool will be extended in order to provide also that detailed information, where the electromotors are, where the magnets are, which products, which elements are in the magnets. It's a first step and an easy step to go forward. When it's quite possible, and as far as I know, the car industry is working on another object, Catena X, where more information might be available. I don't know when that system will become available, but unless this system with more detailed information is there, this is an opportunity to already comply with the information requirements.
Thank you, Julien. I think that we have borrowed enough of your time, of your extra time. So please give a big applause to our panel and the panel before. Thanks for being here, and see you maybe soon.